This is R.D. Sharma, Solutions, Class 10 Maths, Chapter 15, Exercise 15.3. Now this exercise is related to the area of circle, specifically with the minor and major segment questions. AB is a chord of a circle with center O and radius 4 cm. So here we have a circle, and this circle we have a chord. AB is a chord with center O and radius is 4. Radius is 4, and AB is of length 4 cm. This is 4, this is 4, this is 4, and divides the circle into two segments. So this shaded region is the minor segment and the other region is the minor segment. Find the area of the minor segment. So here we have the direct formula which we can use directly. But first we have to know the length of the chord if we want, and the angle, because the angle is not known. See, in the question the angle is not given. So this is 4, and this length is given. This length and this length is given. It's because this is radius and the chord length is 4 cm. So all the lengths are equal. When in a triangle, when all the sides are equal, all the angles are equal, that means this triangle is an equilateral triangle. Equilateral triangle. So what is the angle here in an equilateral triangle? Because all the sides are equal. All the sides are equal. So angles are 60 degree each. This is 60, this is 60, and this is 60. So now theta, the chord which subtend an angle at the center is 60 degree. Now the formula goes like this. See, r square radius square we have to write outside. Then we have theta by 360 into pi. Then we have to subtract sine theta by 2 cos theta by 2 from this. And this has come from where? This has come from, see, this is the sector. So the sector is simply, the sector is theta by 360. What is the area of the sector? Theta by 360 into pi r square. And we have to know the triangle. This is an equilateral triangle, whatever triangle. The area of the triangle in this case is nothing but root 3 by 4 side square. Root 3 by 4 side square, that is 4 into 4. So this root 3 by 4 will come from here, sine 60 by 2 and cos 60 by 2, that is sine 30 and cos 30. So it is going to be root 3 by 4, and 4 into 4 is here. This is r square. This is r square. So this is a formula which we will apply everywhere. This is specific, this formula is specific for this triangle which is the equilateral triangle, but you can generalize it for any of the case. So here we will put the values. R square is 4 square, so we'll write 16 here. Then we will write this theta as 60 degree. So you can just keep it like pi also if you want, right? Pi, you can just put it like pi. So this is pi by 360, and we will bring this 16 inside pi, and then we have this r square. So r square is already out. So theta pi, and theta is what? It is 60 degree here, minus root this. I'm using this generalized formula. So sine theta by 2 is, that is sine 60 by 2. So sine 30, which is half, and cos 60 by 2, cos 60, which is root 3 by 2. So we have 16, and then 6 is 36. This is pi by 6. Now bring 16 inside. So you get 16 into pi by 16 by 6 minus. Now this is root 3 by 4. Now this is root 3 by 4, 2 to the 4, and bring 16 inside. So what do you get? You get 8 pi by 3 minus 16. 4 root 3. So this is the answer. And even if you do like this, you will get the same one. A chord PQ. So here we have a chord PQ. And this is of length 12 cm. It subtend an angle of 120 degree here at the center of the circle. Find the area of the minor segment cut off by the chord PQ. Now you can directly use the formula, this one, pi theta by 360 minus sine theta cos theta r square. You can directly use it. But for this we need, first of all, because the angle is given, so we need this radius also, and the area of triangle can also be, known. But we can use directly the formula, so we'll try to use the formula, but only the radius part has to be known. Otherwise this angle is given 120 degree. So we just need to know the radius part, because we'll apply the formula directly. No, we'll not do that. That first we'll find out the sector, then we'll subtract the area of triangle. That we can also do, but this is the direct formula, so we'll use it. So here we have a triangle. In this triangle we drop a perpendicular here. So this whole is what? Because this is an equilateral, this is an isosceles triangle. This side is this side. That is these both are radius. These both are radius, and this whole is your 120 degree. So this will be 60 and this will be 60, because the perpendicular of an isosceles triangle divides the angle, or it bisects the angle. It is an angle divided, the perpendicular is. And this whole is 12, so this will be 6, this will be 6. Now in order to find the radius, if this is the triangle, what we can do, see, I'll use, because this is the perpendicular, this is the hypotenuse, so I'll use sine 60, which is going to be r by 6. This perpendicular, or you can say perpendicular upon hypotenuse, so it will be 6 by hypotenuse r. So sine 60, this is root 3 by 2. So root 3 by 2 will be equal to 6 by r. R will be what? This 2 into 6 by root 3, that is 12 by root 3. Now multiply root 3 in the numerator and denominator, you get 12 by 3 root 3. This root 3 will become 3. So 3 4s are 12. You get 4 root 3. Now you'll use the formula, that is r square, which is this 4 root 3 square. So r is 4 root 3 square. Then theta by 360 into theta by 360 into pi. Theta is 120 degrees. So 120 degree by 360 into pi, minus sine theta by 2 cos theta by 2. So whole theta we have to use 120 degrees. So theta by 2 will be what? 60 degree. So sine 60, we know sine 60 value is root 3 by 2, and cos 60, cos 120 by 2 is cos 60. Cos 60 is what? It is half. So what do you get? 4 root 3 square, 4 root 3 into 4 root 3. So 4 4s are 16, root 3 is 3, so you get 48 here. So this will be 48. And we have what? 120 by 360, so this is going to be 3. So we have pi by 3 minus root 3 by 4. If you want to take this inside, you can do it, because what you get here is, I'm just taking the LCM, so 4 pi minus 3 root 3 by 12. This is 48 outside, so it is 4 times, sorry. So the answer is 4 pi minus 3 root 3. So the basic thing was to find out the radius, otherwise you just have to use the formula. A chord of a circle of radius 14 cm makes a right angle at the center. Find the areas of the minor and the major segment. So here we have to find the major segment also. First we will find the minor segment, this one, and this we know the formula. This will directly use, that is theta by this minor segment area will be equal to, let me make it as mi, minor. This is theta by 360 into pi, so theta is 90 degree here. So 90 by 360 into pi minus sine theta by 2 cos theta by 2, sine theta by 2, this sine 90 by 2, that is sine 45. Sine 45 is 1 by root 2, and cos 90 by 2 cos 45, that is cos 45 is also 1 by root 2. And then we have r square, 14 square. This is our first one. So what do we get? This is 4 times, you get pi by 4 minus this is 3 by 4. Okay, this is 1 by root 2, and so 1 by 2. This is 1 by 2. And you have 14 into 14, that is 196. So pi can be written as 22 by 7, 4 will be here, bring 196 inside. Then you have 196 by 2. So what do you get? You get this has 154, this has 98, so 154 minus 98 is 56. Now this is the area of this smaller segment. So in order to find out the major segment, this whole means we have to take the area of the circle and just subtract this minor one, we'll get the area of the major segment. So what is the area of the circle? It is simply pi r square. Pi is 22 by 7, r is 14 into 14. So what do you get? You get 616. This is the area of the whole circle, and you have to subtract this to get the major part. So 616 minus the minor area part, this is going to be 560 centimeters square. So this is the answer. This is the major region area. A chord of length radius 14 centimeter makes the right angle at the center. Find the areas of the minor and major segment of the circle. So this is just to show that in other way also you can do. This is the another way to solve it. Coming to the next question, a chord 10 centimeter long. So here we have a chord which is 10 centimeter long, is drawn in a circle whose radius is 5 root 2. Find the area of both the segments. So here we have the same scenario. We have a triangle here. We have this as 5 root 2, this as 5 root 2 because these are radius. This, we drop a perpendicular, right? This whole is 10. So this will be 5, this will be 5 because this is an isosceles triangle, so this divides. And this is 90 degree as well. These are the properties, and this angle are equal. So in order to find this theta will be what? I am taking tan theta. Tan theta will be, for this triangle, this will be perpendicular and this will be hypotenuse. So I will take sin theta. So sin theta is perpendicular, that is 5 by 5 root 2, hypotenuse. What do you get? Sin theta as 1 by root 2. But you know this is sin 45. Is 1 by root 2. So this angle is 45. So this angle will also be 45. So this whole angle will be 90 degree. So we got the theta. Theta is 90 degree. Now we can apply the formula directly. So area will be what? Theta, this theta is 90 degree. So 90 by 360 into pi. You can take this 50, this r square. Our radius is 5 root 2. So r square is 5 root 2 square. This will be 25, root 2 is 2. So 50. So you can just bring it 50 and multiply this with pi. So you can use 22 by 7. This is done. Now coming to sin theta by 2, cos theta by 2, sin theta is 90. Sin theta by 2, sin 45 by, sin 90 by 2, that is sin 45. And cos will be same, cos 45. So it will be 1 by root 2 into 1 by root 2, which eventually comes to be 1 by 2. So when you solve it, this will be pi by 4 and this will be, let me directly write the value. This one will be 39.25 and this will be, of course, your 50 is inside. So you get 50 by 2 minus 25. So you get 14.25. And this is the area of the minor segment, this segment. So in order to find out the area of the major segment, you have to do what? You have to take the area of this whole circle and subtract this minor segment. So what is the area of the whole circle, which is pi r square? So it will be 3.14 into r is 5 root 2. So 5 root 2 into 5 root 2. So 3.14 into this 5 is a 25 and then root 2 into root 2 is 2. So you get 157 centimeters square. This is area of the whole circle and this is the area of the minor segment. So in order to find out the area of the major segment, you just subtract these. So 157 minus 14.25 and this is going to come as 142.75 centimeters square, and this is the area of the major segment, this one. A chord AB of circle of radius 14 centimeter makes an angle of 60 degree. Makes an angle of 60 degree at the center of the circle. Find the area of the minor segment of the circle. So here the same scenario is with us. Same scenario, but the angle is given as 60 degree. We'll take half, so I just said 30 degree. So we'll use the formula. So it will be r, the area will be simply the r square. What is the radius? 14 into 14, r square. Then we have pi, 22 by 7. Theta is 60 degree. Whole 60 degree you have to take. 60 pi, this pi by 360. And this minus sin theta by 2, cos theta by 2, sin 30. Sin 60 by 2, cos 60 by 2. So sin 30, cos 30. Sin 30 is was what? 1 by 2. And cos 30 is root 3 by 2. And we bring, this will bring later. So this 14 into 14 is 196. So I'm bringing 196 into this is 6 is 36. So you get 22 by 7 into 6 minus this root 3 by 4. And here you bring 196. So you have to take root 3 as 1.732. So this will become 102.66 if you solve it, and this will become 84.87, and this is going to be 17.80. So the minor segment has been asked, so we found out the minor segment. So this is the first part of this exercise. We'll be taking one more of this. Till then, thank you so much and take care of yourself.